Okay, so we're in the land called 1.7, which is called what comes next, what comes later. And the first question says, what makes a sequence an arithmetic sequence, and provide an example. And so some of you put some awesome examples. So someone said, hey, look, 5, 8, 11, 14. That would be adding by 3. So yes, if you don't have this adding by for arithmetic, then that's not correct. If you put subtracting, that works too. But it's adding by 3, subtracting by 3. Very good. So what makes a sequence a geometric sequence? Multiplying. So if you do not have that answer, please make sure that you put that as your answer. So stop right now, type it in, get that answer on your Desmos screen. As you type it into your screen, make sure it goes into your head. Yeah. Okay, very good. So multiplying, some people would say dividing here, because a geometric sequence, what we learned last time was it was being divided by 3. Do you guys remember that? Or what was it being divided by? I forgot. Whatever number, whatever factor it was being divided by, that also can make a geometric sequence. So again, adding, subtracting, we're in arithmetic land. Multiplying or dividing, we're in geometric land, okay? Very strong work. I appreciate that. So today what we're going to be able to do is determine if a sequence is geometric, arithmetic, or neither. So that person whose whatever work I just showed, they already know how to do that. Boom. Okay, then it says write recursive and explicit equations for arithmetic and geometric sequences. We've been working on this. Very good, right? We've been working on this. And then it says, how can I efficiently use the information in a table to write formulas for arithmetic and geometric sequences? So again, this is not anything new that we are doing. This is kind of like putting everybody all together, okay? Okay, so here it says, I can't read that. Here, so number 1, perform each of the following steps for each table. Number 1, identify if the function is arithmetic, geometric, or neither. You all know how to do that. If not, that person's answer helps. So if the function is neither arithmetic nor geometric, you do not need to find any of the other equations. Oh, okay. So if it's a neither, you don't have to find any of the equations. Okay. Describe how to find the next term. Write a recursive. Describe how the features identified in the recursive can be used to write in an explicit, and then write an explicit. Now, some of you like recursive better. Some of you like recursive better. Some of you like explicit better. It just depends. Okay. So by the way, for those of you who want to be programmers or like computer programmers or anything like that, this recursive rule turns out to be very useful in the land of writing code, okay? Because that's what a computer program will do. If you ask the computer program is to search like through a document for something, it'll crawl through it using a recursive rule, right? Okay, that's a little advertisement right there for you. Okay, so the very first one says, is this arithmetic, is it geometric, or is it neither? Oh, someone answered this. Sorry, my bad. Wait, what happened? I don't know what's happening here. Let me go here. Okay. Oh, so this is our example. My bad. So arithmetic, geometric, or neither. This person said arithmetic, and look, it's almost that same exact sequence that person used. I think it's the same one. Very good. Using your tools. That's awesome. To find the next term, we added 3, which that makes sense, right? Because if it's arithmetic, then we would add 3. Right? That makes sense. The recursive equation, remember 2 parts. Number 1, the starting point, f of 0 equals to 5. Boom. And the next one is next equals previous plus 3. See? Add 3 to previous term. Previous plus 3. Boom. Right? So to find the nth term, we started with 5 and add 3n times. 3n times. So, and then here's your explicit equation. So to find the nth term, this is almost like you describing the explicit equation in words. Okay, so this is what they're expecting you to do. Okay, okay. So with that being said, let's move on to problem 1, which is on page 6. And I'm just going to go to here. I'm just going to take my notes on here already. Let me make this bigger. Very good. Okay. So with that being said, so what do you guys see here? When I first start this, now this is number one, so kind of ignore this top part here. Hold on a second. When you see this top part here, what do you instantly, what's their first, like if someone's lost, what would you tell them to do first? When you look at all this information, what's the first, because it looks overwhelming, does it not? What's the first thing that I should do? Like, tell me what to do. What should I do first? Okay, look at the table, check. Then what should I do after I look at my table? Very good, thank you, thank you. Okay, public chat 2 is okay. Yes, look at the table and then play the game of and someone asked this question, which I love when people ask questions in the chat of when I say, okay, what would the next person do? So someone said, ask yourself how to find the next term. Oh, so how did we get from here to here? Uh-huh. And how did we get from here to here? Uh-huh. And how to get from here to here? Uh-huh. And here to here. Uh-huh. 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 Someone else said, how much is it going up by? Exactly. Someone else said, find the pattern. Someone else said, look at the table and see how much it goes up by. Very good. Someone else said, ooh, they used the fantastic vocabulary. They said, find the common difference. Okay, all of these are fantastic. I would post it to right here because some of these are just to me and not to everybody. Very good, but I don't want to put your name, so I will not do that. So I will do all of that. The very first thing I want to do is I want to go and find, after I look at the table, I want to look at how much it's going up by. So Miss Johnson, she just does this little thing with her pen. She goes, this is going up by 12, right? This is going up by 12. Yay, it's all going up by 12. So right now, because all of this is the same, what do I already know? What do I already know? So I'm going to pretend that this is a quiz, right? If you're stuck right here, there's so much more that you know, okay? Yeah, just from this part here, I'm going to fill out everything that I know in all of these places. Very good. Someone said, Miss Johnson, that's the common difference. Okay, so I'm just going to write common difference over here. I'll write it this way. Oops, that's in. So this is the common difference. Okay. You can call it a common difference, a constant difference. Someone else called, hey, Miss Johnson, that's the slope. Very good. Or the slope. Very good. And someone else said, hey, Miss Johnson, I know that it's arithmetic. Exactly. Because earlier our friend told us that if it's being added by 12, adding means arithmetic. So I already know that it's arithmetic. How to find the next term? How am I going to find the next term? What would you say? Do I already have the answer? Yes, exactly. I'm going to say add 12 to get the next term. Okay. Okay, what else do I know? Well, I already know that the recursive equation is going to be something, something, something plus 12. Something, something, something plus 12. Ms. Johnson, how do you know that? Because that's what this says. This says add 12 to get to the next term. The recursive equation is, well, you'll see, this plus 12 will come out. So I'm going to write this plus 12. My point is if you just know this one thing, look at all this stuff you actually know. Okay. To find the nth term, well, this one was weird, so I'm going to hold off on that one. To find the explicit equation, you all said that this is the slope. So if I write my equation, so if my equation was y equals mx plus b, right? This 12 goes right here. This 12 goes right here. So look at just on this first pass. Boom, I know this. Then you all said, I know this, and I know this, and I know this, and and I know this, and I know this, and I know this. And technically you do know this, right? Right? You do know this. Okay. So the rest of this is you picking off the details here. Very good. That's exactly right. Whoever put that answer in there. Very good. Okay, so now I'm going to pick off all this other thing. Okay, so I answered question A. I know it's arithmetic. You should say, I know it's arithmetic because I'm adding 12 to it. Okay, this is done. How to find the next term. I just add 12 to get the next term. That's done. The recursive equation, if you look up here, right? Do you see this +3? That's my +12. So now I'm going to fill in the rest of this. So I just need the starting point. So I'm going to write this down here. Can you show me in public chat, if you can you write out the public chat, the first term? Can you write in function notation the first term? Okay, I'm going to choose a different color. First term. Yes, very good. Anybody else with the first term? And if it's okay to copy that person, why is it okay? Because if we were in our class, I'd tell you to turn and tell your neighbor, and all of you would be talking at the same exact time. But I need your mouth or your fingers or your brain to produce that same knowledge. Okay. Plus, first answer is just the first answer. It's okay to repeat people, right? That's how I got my own little children to sing ABCs. I'd have them repeat me. Like, okay, now say thank you, mommy. And they'd be like, thank you, mama. See, say it. That's what I do. Okay. So I'm going to write this out. Someone wrote in the chat, they wrote it like this. They wrote f of 1 equals 3 equals 3. So f of 1 equals 3. So Ms. Johnson, how come they put 0 and 5 here? Well, because that was the first term there. 0, 5 matches with 0, 5, right? So let me highlight that so you all see this 0, 5 came from this 0, 5. Okay, this 0, 5 came from this 0, 5. Just like this f of 1 equals to, what is that, 3? Comes from here. So let me, I wish I didn't highlight in pink, but that's okay. I'll highlight in blue right here. So this guy here comes from this guy here. Okay, this comes from this. But then how do you write this f of n business? Well, literally, I'm just going to copy this down because that means next equals previous. So I'm just going to move this guy over because I didn't give myself enough space. So I'm going to write that down too. So f of n equals f of n minus 1. Okay. And so all this really says, and it's going to happen over, you're going to see this over and over again, right? So for those of you who are learning a different language, you're going to see, you know, that's that word over and over again, right? You're going to see that structure over and over again. This is a structure you will see again and again. So Ms. Johnson, for arithmetic, it's always going to be f of n equals to f of n minus 1 plus something. Yes, sir. Yes, sir. Okay. Okay. Okay, so this one's done. And then it says to find the nth term. So here, if you look at this structure here, it says to find the nth term, start with 5. So here I'd start with 3. Right, and then I'm going to add 12 n times. Does that make sense? And then I have to figure out if it's n minus 1 times or n times. This guy right here. This n minus 1. Oh, okay, so this guy here, if I translated it to English, this says next equals previous plus 12. So next equals previous plus 12. Okay, thank you for letting me know. Okay, so for example, if I wanted to find, say, the 6th term here, if I wanted to find the 6th term here, so let's do that over here. This is my little example. I'll do my example in my rainbow pen because he's fantastic. So f of 6, right? F of 6 is equal to, so f of 6 minus 1 plus 12, right? So what's 6 minus 1? Oh, that's 5, Miss Johnson. Okay. So f of 5 plus 12? Yeah. Okay, but what's f of 5? Oh, f of 5 is 51. It's 51. So you want me to put 51 instead of this? Uh-huh. So do you guys remember us practicing evaluating a function a couple of things ago? Yeah, so this is why they have you do it. Okay, so f of 5, Miss Johnson, how did you know it was 51? Because this is my x, and they said you wanted the f of 5, so they wanted the y when x is 5. So this guy right here in normal English terms, okay? In normal English terms, let me write it in my blue, right? This guy here says, what is y when x is 5? So that's what that thing is saying, right? So like if I was translating from math to English, whenever you see f of 5, they're saying, hey, what's your y? What's your y when x is 5? It's like, yeah. Oh, got it. Okay, so what is it? Oh, it's 51. So you want me to put a 51 there instead, Miss Johnson? Yeah. So put a 51 there. Yes. And then now I add 12. Uh-huh. So what is 51 plus 12? 63. I'm going to say that I've been making some careless errors there. So it is okay to say, hey, Miss Johnson, that's not correct. So that question mark over here for f of 6 is going to be 63. 63. Good. Okay, very, very good. So hopefully that's making more sense for you. If not, just keep this structure in your head. Keep this structure in your head, right? Okay, to find the nth term, according to this, it's find the nth term, start with 5. So I'm going to say start with 3. And I'm going to type this one out because I want this one to stand out just a tad because this is the first time that we're doing it. And I like when we make sure that you guys all understand. Okay, so here we're going to say start with, now here, we're going to start with 3. We're not starting with 5 because that's, right, that's that one. This is this one. So I'm going to start with 3 and add 12. So do you see how I'm going to add 12 to it? Now, if I go to n, like how many times am I going to do that? So here to get 2, I added 12 once. To get to 3, I had to add 12 2 times. 1, 2. To get to 4, I added 12 3 times. 1, 2, 3. To get to n, am I going to add 12 n times? This is kind of like the, the exponent thing that we figure out. So my question is, what goes right here? How many times am I going to add 12? 1 time, 2 times, n times, some different number? Does that make sense? So if I look at this pattern here, do you see me adding 3? To get to 1, I added 3 1 time. To get to 2, I added 3 2 times. So that's why it's 3n times. Add 3 n times. Here, we're going to add 12. Now, this is going to be the weird part. N minus 1 times. Ms. Johnson, why is it n minus 1 times? It's n minus 1 times because if I go to 3, how many times did I add 12? 1, 2. Got it? If I go over here, how many times did I add 3? I guess I should add 3 here. You guys all see my 3 right here. Plus 3, plus 3, plus 3. When I get to here for 4, how many times did I add 3? How many times did I add 3? So if you look, it's 1, 2, 3, 4. Oh, it's 4 times. So it's whatever n is. Does that make sense? So here, it's not the same. It is not the same. So look at my 4 right here, right? Or look at your 5 or whatever. How many times are you adding it? Are you adding it n times or n minus 1 times? Am I adding it n times or n minus 1 times? So let me try. Let's see. So 4, looking at my 4 to get 39. Oh, look at 1, 2, 3. So it's not n times. It's n minus 1 times. Does that make sense? Feels a little funny. I know, but that's okay. Just stick with that for now. If this part doesn't make sense, like let's just say, I'm going to move this. All of this makes sense except for this one. That's a win. That is a win. Okay. Last little part, and then I'm going to have you guys try one on your own. Okay. So the next one, it says, try this one. Y equals mx plus b, right? So y is still going to be our y. That makes sense. X is still going to be my X. Oh no. Who's my B? Where do I find B here? Where is my B? You guys should all know who I'm going to reference right now, right? Yes. This is called your y-intercept. Very good. Very good. Let me put this in a pretty color. So this B over here is my y-intercept. It's when X equals to 0. Very good. Oh, man. I don't have a 0. I don't have a 0. No, just kidding. I don't have a 0. So what am I going to do? Yes, I'm going to go backwards. I'm going to subtract. So this is going to be minus 9. Okay, very good. So it's a minus 9, Miss Johnson. Yes. So this is minus 9. Very good. In the chat, I'm going to highlight these guys together. This purple guy came from, we lost him. Can you see that? Let's see. No, you can't. Okay, let's trade colors or something. I don't know. 0, -9. And that's my -9. So that color gets lost in the purple. All right. So boom, I got all this. Okay, let's go back to pretending that this is, did I not do it right? 12. Yeah. Okay, let's pretend that this is a quiz. And you're like, okay, but Ms. Johnson, how would I check this? So I would check this given the data that I was given. So I would pick a number, any number, whichever number you want. I don't know, maybe like 4 and 39. So I'm going to use this 4 and 39 and plug it into everywhere to make sure that it makes sense. So wait, what do you want me to do, Ms. Johnson? I want you to grab a calculator. So again, my friend is Desmos always. So Desmos, oops, that's not Desmos. Try again. Oh man, I apparently don't remember this. Okay, go here. Sorry, I'm just trying to use this bottom screen here. Okay, so I'm going to plug in my 4 and I hope that I'm going to get my 39 out. So I go 12 times 4 minus 9. Yes! Yay! Look at me. I got 39. Look at me. Oh, sorry, okay, so then Miss Johnson, she's really happy. She looks like this. Watch. Yay! Right? She's very happy. Miss Johnson, why are you so happy? Because I know that this is right. And so I'm going to make sure that this is right too. Is f of 1 really 3? Yes. And then if I add 12 a bunch of times, will I eventually get to my 39? I don't know. Just do it. So I go 3 plus 12 plus 12 plus 12. Look, it's 39. Yay. Okay. Last of it. Am I really adding 12 to get the same thing? Is it really arithmetic? Boom. So there goes my first attempt at this. If you have questions on this, what part of this is confusing? Which part of this is like the most confusing? I already know which part you're going to say. Which part do you think is the most confusing of all of this? I think there's 2 parts that you might say. Yeah. So this part here, this to find the nth term is weird because it's new, and that's okay. Right? It's just language. It's just new language for us right now. But you'll get the hang of this. I think the other part that's confusing is this f of n equals f of n minus 1. That's another weird part. But just get used to that structure. Okay, it'll make sense. Okay, so now what I want you to do is I want you to pause the video and I want you to try B on your own. I want you to try B on your own.